All right, so we are moving on to Pythagorean Theorem day 2, and we are going to actually look at the theorem itself now. Did I lose my writing? I did. Now I have to rewrite Pythagorean Theorem. That's just sad. All right, so I got this though. Pythagorean Theorem. And this is day 2. And yesterday was day 1 of this unit, but we just learned yesterday how to simplify radicals because you'll see here in a second, when we start using the Pythagorean theorem, we're actually going to get answers that are radicals, and we have to learn how to simplify them. So, first of all, what is the Pythagorean theorem? Well, it is the theorem that tells you how to solve for a right triangle. And you know it's a right triangle because it's got the little square in one of the corners. And if you know 2 of the sides, using this theorem, you can always solve for the third side. And it doesn't matter which 2 you have, but know that the legs are A and B. Okay? And the legs are always the 2 sides that come together to make the right triangle. Now, A and B are interchangeable. Okay? It doesn't matter. I'll try to draw this exact triangle again here. Okay, here's this exact triangle. You can call this one B and this one A. The legs don't matter which one's A and which one's B. What is very, very important is which one you call C, because C is always the longest side, also known as the hypotenuse. Okay, it's the longest side, and you can also, if it's too close to tell with your eyes which one is longer, the hypotenuse is always the side directly across from the right angle. So when you're looking at a triangle, 2 sides come together to make the right angle. That's always A and B, okay? And it doesn't matter which one you call A and which one you call B. The side opposite the right angle is always C, okay? It has to be C. And if you don't recognize the hypotenuse as C and you name it A or B, you're not going to get the right answer. Okay? So A and B are interchangeable. C is always the hypotenuse. And you may not always see a triangle written like this. Sometimes it could be something kind of funky like this. And your right angle will always be identified. So if I said label these sides, A and or B doesn't matter. AB doesn't matter, but directly across from the hypotenuse has to be C. So no matter what way it's tilted, the 2 sides that make up the right angle are always your legs or your AB. The hypotenuse is always C. Okay, good with that? Now, the actual theorem itself, or the equation, is A squared plus B squared equals C squared. And looking at this equation, you can kind of see why it does not matter which one you call A and B. Because 2 plus 3 or 3 plus 5, they're both... I said the answer on the second one. 2 plus 3 or 3 plus 2, they're both 5, right? Doesn't matter. So B squared plus A squared is the same as A squared plus B squared. We're just used to saying it in alphabetical order because it just kind of flows out better. But what's important is notice on the other side of the equation is the C squared. So that's why it's really important that you label C as the correct one and that it is correctly C. Yes?
Are we going to get into like C squared minus A squared?
Yes. So sometimes you'll be given A and C. And if you're given A and C, I don't ever have you rewrite the equation. To me, I think it's easier to always remember A squared plus B squared equals C squared. Don't try to get fancy. Now, what you're talking about is if you're given C and B or C and A, what I like you to do is I like you to still plug it in, A squared plus B squared equals C squared, and then just do basic algebra to solve for whatever's missing. So yes, it works that way, but sometimes trying to memorize all the different variations is a little bit trickier than just remembering A squared, B squared, C squared, and then doing your your algebra like you know how to solve for it. And we'll do examples like that here in just a second. All right, so let's do an example when you're going to be given these in two different ways. The first way is you're going to be given A equals, B equals, and C equals. And then another way you'll be given it is you'll be given a drawing and you'll be given a couple of sides, and then you've got to find the missing side. So first, let's do an example where you're given the value. So you're given A equals 5, and you're given B equals 12, and you don't know C. C is the unknown, okay? So again, keep in mind, A squared plus B squared equals C squared. That is always your go-to equation. So I'm going to plug in, for A, I'm going to plug in a 5. For B, I'm going to plug in a 12. And for C, I'm just going to leave it C squared because I don't know what C is. That's what I'm trying to find. PEMDAS says we do powers first. So I square 5 and I get 25. And I square 12 and I get 144. And I'm just going to leave C squared alone right now because I don't know what C is. Now I need to add 25 plus 144, and I get 169 equals C squared. Now, we've talked about this. The opposite of a square is a square root, which means anytime I want to undo something, I always do the opposite. So I'm going to square root and square root, because when you do it to one side of the equation, you always have to do it to the other to keep math fair. The square and the square root go away, leaving me with just my lone C, which is what I need. Now, the best way to do these is on your calculator, hit your little square root button and then type 169 and hit equals. If you get a whole number, it means it's a perfect square and your radical goes away. And in this case, you get C equals 13. Okay? If you get a decimal, then stop, don't write the answer down, and I'll show you got to do what we learned yesterday, which is simplify a square root. Because we are not converting these to decimals and rounding. We're doing exact answers. And exact answers, remember when we were messing with pi and I said exact answers, you leave the pi in there. You don't substitute 3.14 because that's a rounded variance. Same thing with this. If I were to ask you what's the side length rounded to the nearest hundredth, then you would just punch it in your calculator and round that crazy decimal to the nearest hundredth. But if I want the exact answer, then you need to simplify the radical, okay? But in this case, it doesn't matter because the square root of 169 is perfect. It's 13. So your answer to the side of C is 13, okay? Now, another way you might be given the information is you might be given that this side length is 4, and we'll do 4 inches. And then you might be given this side length is 8 inches. Okay? And you're asked to find the missing side. Well, first of all, you have to decide what's A, what's B, and what's C. So, Atticus, what are you going to call A? Okay, we're going to call this side A. Montana, what are you going to call B? The 8 side. And, of course, the side opposite the square root, that's our C, or our unknown. So we're going to plug it into A squared plus B squared equals C squared. So we're going to have 4 squared plus 8 squared equals C squared. And we don't know what C is yet, but we have to put C squared because that's part of the equation. A squared plus B squared equals C squared. Now we're going to square A, and we get 16. And we're going to square B, and we're going to get 64. And we're going to leave C squared alone because we don't know that yet. 16 plus 64 is 80 equals C squared. Well, now I'm to the part where I need to take the square root of both sides. Now, punch it in. I want everybody to do this. I want you to punch in your calculator the square root of 80. And tell me what you get.
8.944.
Okay, Gabby, what'd you get? Punch it in. Atticus, what'd you get?
I don't have a calculator.
Okay, you need to get one. Always need to get one. Okay. Okay, punch in the square root of 80 and see what you get. Did you get it? What'd you get?
8.94.
Okay, since you got a decimal, we're not rounding, we're not guesstimating here. We want the exact answer, which means we have to come out here to the side and we have to simplify the square root of 80. And then we're going to put our simplified answer as our answer for C. And the reason we have to do that is because we have to take the square root of this side to make C come out by itself. So that means we have to take the square root of 80, but we want the simplified version. It's even, so 2 and 40. It's still even, so 2 and 20. And if you're not sure, take 80 divided by 2, 40 divided by 2. 20 divided by 2 is 10. 10 divided by 2 is 5. I'm at all primes, so I can circle this pair of 2's. It comes out as 1. I can circle this pair of 2's. It comes out as 1. And what couldn't be circled is my 5, so it stays trapped under. So my final simplified version, which I'm going to put C equals, is 4 square root 5. Because I'm replacing this right here, this square root of 80, with the simplified version of the square root of 80. And that is my final answer. Now, why can't I leave it right here at this step? Yeah, because I need the value of C, not the value of C squared. And when I got to this step right here, I had C squared equals, but that doesn't tell me what C equals. So back up on my picture of my triangle, my C side would equal 4 square root 5. Now that looks like a weird number, but that's okay, all right? Because that's the exact answer, is C equals 4 square root 5. And if you wanted a rounded version, it was that 8.94427, blah, 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 goes on forever, okay? All right, any questions with that? All right, let's do another example here, but this time we're going to be missing something different. So this time we've got A equals 4, B equals we don't know, and C equals 12, okay? We still start with the A squared, B squared equals C squared. So we're going to do 4 squared equals, nope, not equals. 4 squared plus B squared, right? A squared plus B squared equals 12 squared, or C squared. Now I'm going to do all my squares first. So I've got 16 plus B squared equals 144. Now this goes just back to your basic knowledge of algebra. I need to get B by itself. There's a 16 over there that I need to move. And so anytime I need to move it, I'm going to do the opposite. It's a positive 16, so I'm going to go minus 16 and minus 16. So I get B squared equals, thank you, Bryce, 128. All right, am I done? Nope, because I need to know what B equals. So I'm going to square root and square root. Remember, the square and the square root cancel each other out, leaving you your B all by itself, which is what you wanted. Punch in your calculator the square root of 128. If you happen to know whether or not it's perfect or not, you don't have to do this, but what'd you get, Corbin? Okay, so that tells us it's not perfect. So we need to come out here to the side, and we need to take the square root of 128, and we need to simplify it. It's even. So I'm going to take 128 divided by 2, and I'm going to get 64. Huh? Yep, 2 and 32. 2 and, what's next? 16. 2 and 8. 2 and 4. Ooh, barely squeezed it in there. 2 and 2. It is a lot, but that's okay. We still do it the same way. Circle this pair of 2's. They come out as 1. Circle this pair of 2's. They come out as 1. Circle the next pair of 2's. They come out as 1. And then what can't come out is this lone guy down here. He's trapped. And so your final answer is 2 times 2 times 2, which is 8, square root 2. So we come back over to our problem, and the reduced version of the square root of 128 is 8 square root 2. And that would be your final answer.
It looks so complicated.
It's not. It's really not. So, Bryce, and I think this is what you were talking about when you said, are we going to get into C minus? This is where that comes in, but I don't like to memorize a bunch of different equations. So I like to just stick with a squared b squared equals c squared and then move stuff around as you need to.
We won't do decimals, will we?
You will not have any decimals in this because I want exact answers. And so this right here is your exact answer. If I ever said, like if I had a quiz and it was a bonus question and I said round your answer to the 100th, you could put square root of 28 in your calculator, hit equals, and I think you got what, 11 something? 11 point, yeah. So you can write that, but remember that's not an exact answer, that's a rounded answer. And unless you're told otherwise, you always want to give the exact answer. Okay? Good there. Let's see. I want to look at your worksheet because I threw in some challenge ones here, but I think you guys can handle it. So I want to show you a challenge one, okay? Because there are a few challenge ones on your worksheet, and I want to show you how to work them, okay? So we've got, this is going to look weird at first, but hang with me. And you guys have the knowledge to know this. We're just going to talk through it because the first time you see it, it's going to be like, what? Oh, not equals. Sorry. I was talking and writing at the same time, and that didn't go so well. All right. So, a squared. A is square root of 6, but then the formula says a squared, right? Plus b is the square root of 75, but the formula says square that. Equals c squared. A squared plus b squared equals c squared. Make sure this one's down in your notes because you will have some like this on your homework. What have we talked about happens when you have a square and a square root? Square and square root do what to each other?
Cancel.
What happens to that 6? Pops out free. What happens to the 75? Square and square root cancel out, pops out free. Now we keep going just like we do. 75 plus 6 equals 81. Now we don't want c squared, right? We want c. So square root both sides. Again, the square and the square root cancel each other out. And if you don't know it, go ahead and do it, but punch in your calculator. The square root of 81 equals, and this is an example of, see how you got a whole, everybody punch that in your calculator. Square root of 81 equals. If you get a whole number, that means it's perfect, and you don't have to do that step out to the side of factoring. So C just equals 9. Okay, and there are some like that on your worksheet. And then on the back of your worksheet, there are drawings like this where you're given either A and B or A and C, or you're given two side links. So the front, you're just given A, B, and C. On the back, you're given drawings, and you have to decide what's A, what's B, and what's C. Okay, makes sense? All right, so for those of you at home, go ahead and click Load on Cami, and that'll open your assignment. Please make sure and show all of your work, just like we did in the notes, where you plug it into the formula, then you solve, and then if it's required, you need to do out here, out to the side, and factor your imperfect radicals to get them as reduced as possible before you circle your final answer. And email me if you have any questions.